administrator, close the quote, and then alter the add some additional SQL keywords. In this case, just and true. Then comment out the rest of the string after that. So the final query that ends up going to the database just tells the web application, I'm the administrator, never does the password check. So our solution here is analysis and transformation. We take a compiled Java program, its class files and jar files, input them into this transformation tool, disassemble the Java bytecode into an intermediate representation that we can analyze, go through this code looking for signatures of SQL execution statements, the standard Java database APIs calls, backtrack from those calls to find all the fragments of strings that went into constructing that query. So the parts of the string which correspond with the actual SQL keywords, like select, from, where, that define the way that query works, are going to be in relatively static strings throughout the program, concatenated with user inputs here and there. So we can find those static pieces of strings, transform them in a way that the attacker can no longer know the correct SQL language, then output the transform version of this program with this applied. I can get my mouse over here. I'll go in depth a little bit more. I said the general idea here is an instruction set randomization. So we have our basic initial SQL statement, takes user inputs directly in. So normal injection can just alter that statement however they want. Now if we randomize this, so now instead of select and from, we use some transformed pseudo-encrypted version. Now when the attacker goes to inject their command, now they're writing normal SQL and instead of the transformed version. So now instead of a successful injection, the attack's been reduced to a benign syntax error. So how we do this, on the left we have some example code. It's been compiled down into a class. We disassemble it into this intermediate representation using a tool called soot, which it's easy to analyze, static single assignment form. We can go through, look for particular function signatures, and then do backwards data flow analysis. So the result of our analysis, we find down at the bottom, we find the actual SQL execute sync. Trace backwards there from that sync to find how that string was constructed, all the string operations that went into it, and then find the string literals, the constant parts of the string that we want to transform. So we can trace back, find how all different parts of the string are concatenated until we find these static pieces. So once we have those, we can go back into the code and transform it. So now everywhere there was one of those static string literals, we wrap it in a transformation function. So now that string gets transformed by this function when the code's executed, ideally every time a new session comes in or a new query comes in. And then just before the query is passed off to the database, we do the reverse transformation and do a syntax check. Make sure that the query coming through is proper, well-formed SQL. If an attacker tried to do an injection, the reverse transformation wouldn't have occurred correctly, and we'd end up with a syntax error. So then we can block an attack before it actually gets out to the database, throw back an exception, stop the code. Let's go back. Using my mouse pointer, sorry. So I got a small demonstration of this. Let me get my web browser over here. So I put together just a trivial little demonstration of a web message board. Log in as some user, Alice, her password. Go in, we have various forums and topics. So now one of those pages is vulnerable to a SQL injection. All the inputs about which form to list and which topic in that form to show are just done through unchecked input straight into the command line. So if you have the standard query was select as a password check, looks up the username and password of that user, compares their input with what's in the database. But the vulnerability is that one of the fields that's input never actually gets checked. So if instead of a normal input we use this SQL fragment that puts in that form name, closes the quote, and adds in an additional query to post the contents of the username password database. So on this, I think down at the bottom is what the query that actually gets sent to the database. So the result here is a broken demo. Always happens. So now what would have just been the list of topics also ends up having the username and password database appended to it. So now in the other tab here I have transformed version. Yeah, that's what should have appeared. If we go back and do the go back and try to do the same injection again on this transformed version of the program. Now it noticed that some code was in there that wasn't transformed properly, and noticed that that union keyword wasn't a legitimate keyword in the transformed version of the query. So it just truncates the query at that point and only returns the legitimate contents of the database that should have been returned. So we can do that. This is a fairly trivial case, but we can do that for any Java program that constructs its SQL queries in a way that our analysis can handle any kind of program up to pretty reasonable levels of complexity. And as far as performance overhead, I think adding additional passes of syntax checking, randomizing text, doing find and replaces, ends up, when compared to the actual performance cost of going out to a database, interpreting SQL, returning it to a web application engine, constructing an HTML page, returning it to a user, utterly dwarfs the performance cost of doing this randomization. So it would have been a fairly expensive defense instruction set randomization and how it's traditionally applied to binary code as it's executing in a native binary, ends up being pretty acceptable performance for a high-level interpreted language like SQL. So that's how we've dealt with command injection, particularly, okay, in that case SQL, but you can also apply that same idea to any program that we can analyze sufficiently to do that trace back of command sync to user inputs and command construction. And for any command language that we have